Okay, let's solve this LeetCode problem. This LeetCode problem is the daily problem of yesterday. I did not solve it yesterday. I solved it today, so I wanted to share the solution. I'm actually super late for those who who are keeping their streak up in LeetCode. But let's see what the problem says. We're given an array, an integer array, and an integer k. We have to find the length of the shortest non-empty subarray of num's array with a sum at least k. And if there is no such subarray, then we return -1. So for example, let's look at the example 1. Num's 1 is, it has only one element, and k is 1. Then the smallest subarray, non-empty subarray, has a length of 1, this subarray, which has a sum of at least k, which is 1. In this case, we do not have any subarray where the sum is greater than or equal to k. For this case, the whole array, we have only one subarray with sum greater than or equal to k. This is this array, -2, -1, and 2, with a sum of 3, at least, and it says that at least 3. So this is the answer, 3. So let's see how we can solve this problem. Now let's say we're given this array and the k is 7. We have to find the smallest subarray, the length of the smallest subarray, where the sum is at least k. Now we can use sliding window, or what you call a two-pointers approach, whatever you call it. We can start a window here. We can start from this point, and then we can expand the window. We have currently a sum of 1. Right, then we include 3. Now this 1 plus 3 is 4, still less than k. Then we include 4. Now up to here, now we have a sum of 8. 8 is a valid sum, so because it's at least 7, right? Now it's greater than 7 actually. So then this is a valid subarray, and it has a length of 3. Now what do we do from this point on? Now we have a window of this size. Now obviously if we expand our window to the right from this part here, if we include 2 or 5, we're going to get a valid subarray again. So if we include this 2, the sum is going to be 10. 10 is greater than 7, and it is also valid. So this only increases the subarray size. So we don't want to do that. Instead, when we know that we have a valid subarray, we want to decrease the size of the current subarray from the left by excluding some values. We can, for example, exclude 1. So this 1 that we excluded, and we go to here. Now we have 3 and 4. 3 and 4 is still greater than 7. It is a valid, sorry, it's equal to 7. So it's valid. So we update. Previously we had a subarray of size 3. Now we have a subarray of size 2. This is the answer. It gets better. Now we exclude again. Now we exclude 3. Now we have 4. 4 is smaller than 7. So in this point, in this case, we expand our window from this side. So now that we have sum less than 7, we can include more values. We can include 2. The sum is now 6. Now this 6 is still less than 7. We include 5 as well. Now we have a sum of 11. 11 is greater than 7. This is valid. So the size of this subarray is 3. So update the answer. So we have a better one. So we do not change anything. So we keep doing it. Since we have a subarray of size 3 with a sum of 11, we do not increase the subarray size, because by increasing subarray size we would get a valid subarray, because the sum will keep increasing. It is still valid, and we will make it even bigger. So it's 11, and we would make it 12 if we include 1. So we know this fact that when we expand the window size, when the window is valid, we're actually increasing the sum, the current sum, the sum of the window. This is always the case. So we remove a value from the left. When we do that, when we have a valid subarray and we remove a value from the left by basically shrinking the window, when we know that when we shrink the window, the sum is going to get smaller. So this is the fact, and we also know that, as I said, when we expand the window, the sum is going to get bigger. So this is two facts that are always the case, that are always true. This is sort of an invariant. So for this problem, it is possible to use 2 pointers. We have this pointer in here, this pointer here, or rather this is a sliding window, whatever you call it. But our current problem, the original problem, this sliding window, the way that we use it here is not possible. You'll see why in a minute. I'll explain it in a minute. But for this problem, the sliding window is the way to go. You can use it, the sliding window or 2 pointers, the both way, whatever you call it. Now let's move to the actual problem. Okay, now let's solve the original problem. I did not actually construct an array. Let's just solve it in a high level. You can always construct an array in any way you want. Again, k is 19. So we have to find the shortest subarray where sum is at least 19. Now we have negative values in our original array. Well, let's see why we cannot use 2 pointers or the sliding window. Imagine that we have currently this window here, right? Where now there's 2 possible cases, where sum is less than 19 or sum is greater than or equal to 19. The first case, when sum is less than 19, this is not a valid subarray. In our previous problem, when the subarray is not valid, what did we do? When the sum, the valid means that sum is still less than k. So in our previous problem, we expand the window because we certainly knew that the sum was going to get bigger. In this case, this is not the case. We are uncertain about that because we have negative values. When the sum is less than 19, yet the idea of adding actually not a value, so expanding the window, is not the case for this problem. It is not possible because yes, we might have a positive value here, and this would make the sum bigger, but we could actually have negative as well. So this is going to make the sum smaller. So there isn't a way to be certain about what to do in case when sum is less than 19. This is also true when sum is greater than or equal to 19. Well, if we have sum greater than or equal to 19, at least we have a subarray, we know that the current subarray is valid. But then what did we do next? In our previous problem, when we know that a subarray is valid, then we shrink the left side. This is usually the case with the problems that can be solved 2 pointers and sliding window. When you have a problem and it asks for some subarray with some certain condition or property, then you have a sliding window. And within this window satisfies your condition, your property. It has the property. So we call it valid. So then, usually you do, depending on the valid or not valid, so we do 2 things. We either expand the window or we shrink the window from left. And we expand the window from right. So when we knew that the array in our previous problem, it is not valid, we expanded the window to make it valid. When it is valid, we shrink the window because we wanted to, depending on the problem, it might ask for longer subarray or shorter subarray. So since it asked for a shorter subarray, we removed some element from the left, shrink the window to have, when it is valid, to have a smaller subarray and try to have still a valid one. And if it is not valid, we expand it from right. So we knew, depending on the valid or not valid, we knew what to do. And we also knew that what is going to happen if we expand the window or we shrink the window. But in this case, we're not certain about that. And if we expand the window, the sum might get smaller, the sum might get bigger. And also the case for this one here. The sum might get, now you have the sum 9 greater than or equal to 19. If we shrink the window, basically excluding it, we might exclude a positive value. So we like get rid of this positive value. We just remove this positive value from our current sum. Then this is going to make sum smaller. Or it could have been a negative value, -5, let's say. And then we might make the sum bigger, and yes, we would have a smaller subarray. This is actually the point, that this is actually the idea that we will use to solve this problem. Then when we exclude a negative prefix, we make the current sum bigger. This is actually the case, but it has not much to do with the sliding window. Now we know that the sliding window is not going to work because we're not sure about expanding or shrinking in any of these two cases. We'll pursue another method, but before I actually reach this solution, the actual solution, I also thought about the sliding window, and I had actually other ideas, but then I abandoned it. They would work, but to me it looked complex, and then I just said, okay, let's just move to another solution. Maybe there is another way to solve this problem. Now let's move to the actual solution. Now let's proceed with a different idea. We're given this array, and k is 19 again. Now, I didn't actually construct the array again, so we don't need that. Previously, we said that when we have a subarray like this, so now we knew that we cannot. Now we know that we cannot use sliding window. Let's say for this subarray, sum is 12. Now, it is possible that there is a subarray starting from somewhere here to the point that we are, where the sum is greater than or equal to 19, right? So basically, it's a valid subarray. So for this case, that means that when we exclude this prefix subarray here, that whatever the sum of this prefix here, the sum of the remaining part becomes greater than or equal to 19. Currently, the sum of the whole subarray is 12. And then we remove something, a value x, that makes the sum greater than or equal to 19. Or basically, it just makes the current sum bigger. So what this x could be, if x is 1, for example, or 2, for example, what we do, we're actually removing a positive sum from our current subarray sum, which makes it less. So it will make it 10. So we know that this x is a subarray where the sum is negative, because if we remove a subarray, this, I'm talking about this subarray here, the prefix of some prefix subarray. Then if we remove this from our current subarray, where the sum is negative, it has a negative sum, then we actually increase our current sum of our subarray. When we remove -2, let's say this subarray here has -2, then we remove that, then we get rid of this -2, then we make our sum 14. So now our sum increases. So this x is a subarray, is the sum of the subarray where the sum is negative. So we have to remove. But when we have 12, right? What is the best, what is the the optimal strategy here? What would it be? So we want to remove the smallest negative value, because when we remove, let's consider we remove -3, this would make it 15, and we remove -5, this would make it 17. So we're removing the smallest negative value makes our current sum bigger. It makes 17. So we always greedily remove the smallest negative value, because it's going to make our sum closer to the k. At some point, if we, for example, remove something like -8, this would make our sum 20, which is a valid subarray. We would have a subarray with sum 20. 20 is greater than 19. This is a valid subarray. Okay, we said that we could have a subarray where the sum was greater than or equal to 19, like this one here, and thus valid. For example, from here to here, it is a valid subarray. For this reason, we have to remove our current subarray, which has a sum of 12, a value, a prefix of this subarray where the sum is x, and x is negative and as small as possible, so that we can make our current sum as big as possible, so that we can have a subarray bigger with sum bigger than 19 or equal to 19. So now let's say we have a subarray prefix here, where the sum is -10 and it ends at point 2, at index 2, somewhere, let's say here. And we have -8 and it ends at, let's say, 5, like somewhere here. And let's say our current index here, I, is 7. So what do? We said that we remove a subarray. Let's say we have two subarray. This is 2 and this is 5 index. We first remove the subarray with -10. This is going to make sum. So then we remove 10. This is going to make sum 22. 22 is larger than 19. That is a valid subarray from this point to I, to the index 7. So we have a subarray of length 7 minus 2, 5. So the remaining subarray has a length of 5. So we update our answer. We say, okay, we have 5. Okay, now we remove. So then we move to the 8. Now we have 8. We subtract 8, and this is going to be 20. 20 is still bigger than 19. So from this point, from index 5 to 7, for 7 minus 5, we have a subarray of length 2. We have a better answer now. So we update our answer to 2. Now let's move to a different case where we have more negative values. Now let's say we have 5 subarrays with negative sums. By subarray, I mean the prefix subarrays, where we have negative sums. For 12, we first grab 10, and 12, and we grab -10, and we remove this subarray. It is something like, say, here, right? Then we remove this subarray. This leaves us a valid subarray with sum 22. So 12 minus -10, this is 22. 22 is greater than 19. So we update our answer, and then we get rid of this -10, and we move to the next smallest negative value. We have -8. We subtract -8 from 12. We get 20. 20 is greater than 19. This is still a valid subarray. So we take its, we update our current answer, and we also we also get rid of 8. And then we move to -5. -5, 12 minus -5, it is 17. 17 is less than 19. It is not a valid subarray. Removing the sub prefix here, the prefix subarray, leaves us a subarray of sum 17. So sum 17 is less than 19. So -5, removing this subarray gives us an invalid subarray. So we do not want that. So we stop here. And we do not check other values because they will also give us an invalid subarray. So this gives us 17, this is going to give us 15, and this is going to be 14. All of them are less than 19, so we do not even try them. So at 12, we had only two possible ways of removing subarrays. We have -10 and -8. We remove both of them and take the smallest one. Now, what do we do next? We decided to include another element. Let's say from right. We move to the right. We include something here, an element from here. Let's say this is index 7 and this is index 8, right? As we said, there are two possible ways, the possibilities. We might, by including this value, we might increase sum or decrease sum. Let's say we increase the sum to 14. It could be that this value is 2. Or we decrease the sum to 10. It can actually be -2. So there's two possible cases. Let's first look at this one. If we increase sum from 12 to 14, now current sum, let's say 14, what happens? Now we have 14 now. We remove -10 and -8. Okay, if we didn't remove -10 and -8, well, -10 and -8, these are valid for 12. What I mean, like, if we removed this -10, a prefix sub here, subarray with -10 from 12, then it gave us a valid subarray, and also for -4, it gave us for a valid subarray. So it basically increased sum so that it is greater than or equal to 19 when sum was 12. Now, since they are valid for 12, they're also going to be valid for 14. So we do not have any concern at this point. So we can move with the remaining values for 14. So 14 minus -5, this gives us 19. So 19 is greater than or equal to 19. This is valid. So we also get rid of 5, and then we move to the next values. So 14 minus -3 is 17. The 17 is less than 19. That we stop at this point. For 14, we removed only -5. So our concern about the previous removed values was that should we remove them? Like that was the question. Yes, for this case, if we increase our sum from 12 to 14, whatever worked previously for 12 is also going to work for 14. What I mean, like, we removed -10. Let's say this subarray had -10. We removed that for when sum was 12. this gives us this subarray, right? When sum was 14, it is also going to be, when removing -10 is also going to give us a valid subarray, but it is going to be bigger. So there's no point in keeping them. So -8 is also the case. So we do not want that, since we want the smallest one. A bigger one is not of any interest. So it is fine to remove -10 and -8 for the case when we increased sum to a bigger value. Now let's look at a different case where we decrease the sum from 12 to 10. Okay, for 14, our concern about -10, remove -10 and 8 is clear. So it's possible to remove -10 and -8. Now let's look at 10 here. Okay, for 10, now current sum is 10 for this subarray. Our new subarray. It is 10. Now we have -5. If we move with -5, so 10 subtract -5, it's going to give us 15. But 15 is not valid. It is not a valid subarray since it's less than 19. But you might be saying, okay, if we didn't remove, so we hadn't removed -10, we would have had a valid subarray. So you're right if you're thinking this. If we didn't remove this -10, then what do we have? What would we have? Like -10 minus -10, this would give us 20. So basically, if we didn't remove this subarray, look, this subarray would have a sum of 20. 20 is greater than 19. Yes, you're right. This is a valid subarray. But is it better? Is it better than our previous value? So we removed -10 for 12, which gave us this subarray right here. And we removed, and you say that, okay, let's keep -10 because we'll have 10. So if we keep -10 because of this 10, then when we remove it, it gives us a valid subarray. But look at the subarray here. It is longer than our previous subarray for 12 when sum is 12. So there is no point in keeping -10 or -8, even -8 for this case as well. We made it clear for 14 that it is okay to remove -10 and -8, and we actually made it clear for 10 that it is possible to remove -10 and -8 and proceed with the remaining values for the current sum. So in both of these cases, our idea of removing the smallest negative value, this is fine. So basically, how did we solve this problem? We have a sum for our current subarray, and we said, okay, if it is not valid, or whether it's valid or not, let's subtract a subarray prefix like this one, where it has the negative value, and its value is as small as possible. So basically, well, this might sound a little weird, but we do not have to concern about the positive values, because if we subtract a positive value from our current sum, it's going to make it less. So we do not want that. We want to make our sum bigger so that it becomes greater than or equal to k. So we have a sum for a current subarray. We subtract the smallest. Yes, we can say that we subtract the smallest value, which is going to end up being a negative value. So we subtract -10, for example, and then we subtract the next smallest, -8. And we can safely remove these values, -10 and -8. And then we can move to the next value. We can add to our current sum next value, where this one, for example, here. You can make it larger, like 14, or you can make it smaller, like 10. And for these two cases, we showed that it is fine to remove, so you do not have to concern about the removed elements. Just whatever you have in the remaining in your possession, we have -5, -3, -2. Just try to remove this subarrays to see if you get any smaller valid subarray. So now in code, how are we going to keep track of these values? Well, we have to find the smallest value. The smallest value. It does not have to be negative. The smallest value out of values, right? Then what do we use? Priority queue or heap, the mean heap. So we're going to use mean heap, and then we're going to extract the smallest value. And if it gives us a valid, for example, when we're 12 minus -10, it becomes 22. It gives us a valid subarray. Then we remove -10 and move to -8. So then we remove -8 and move to -5. At this point, we stopped when sum was 12. So basically, this is how we keep track of these values. We extract the minimum value. We check if it gives us a valid subarray. And yeah, this is how we solve it. Now let's move on to the code. Okay, here's the code. The code is quite short. We have a priority queue here. I assume that you know C++, but you don't actually have to. You can implement the idea in any other program languages. The main thing is the idea, not the program language. You can implement the solution in any other language, and there won't be many significant differences. So we have priority queue. You do not have to be concerned about what's going on here. It is just a mean heap that gives you the minimum value. And also keep track of the index, because we need this. When we remove a subarray that has the, let's say we remove -10, but we have to know where this subarray, the prefix, it was basically the prefix, where this subarray ended. So then we subtract from our current index. This gives us the length of the remaining subarray. Then we have the answer, the int max. Then we go on, then this priority queue. Okay, I don't know how to explain this, but I'm just going to leave that. Okay, let me say, when we have, I'll show you at the end. Then we add sum to the current value to our sum. As long as the sum minus top, this basically extracts the minimum value. As long as this is sum minus, we subtract the minimum value, it is greater than or equal to k. We update our answer and we remove it from our priority queue, from our min heap. And then we add this sum. Well, the sum here could be positive, as I said that we have to deal with negative values. We only want to subtract a subarray with negative values. But since the priority queue finds the minimum value, it doesn't really matter if this is positive or negative. As long as there is a negative value in the priority queue, it gives us this negative value. So we can just safely push whatever we have at hand. The sum here actually could be like positive, but it is possible to just push that into the priority queue. At the end, we're going to check if we found such a subarray. If we didn't, so the ans did not change in this process, so in this case we return -1, otherwise we return the answer. Let me actually explain this case for the first example of the problem description. If you look at this test case here, we have K1. Basically it asks find the shortest non-empty subarray with a sum at least 1. So when we include 1, the current sum, that we have only one element. Sum becomes 1, right? Then we look for a value that is the minimum value now prior to q, but we do not have any. But if we do not have any, then we do not update our answer. So then we do not have any other value. Then we have to break out of the loop, and then we return -1. But we have actually a value. We can subtract nothing with a sum of 0. Basically, when we have a 1, we subtract 0. The 1 itself is the current prefix, the current subarray. We have only just one element, basically. It has a sum that is at least k. So basically, we subtract nothing. We don't have to do anything. This 0, -1 denotes nothing. It just says an empty array before the subarray, before the start of this nums array, where the index is not actually, it does not actually exist. We have -1. So from 0, when we have 0, the index is going to be 0. We grab the smallest value in this case, in the priority queue, it is 0. So it has -1, index is -1. From 0, we subtract -1, the indices. 0 minus -1 is going to give us 1, and now we update our answer to 1, and then we break out of the loop. At the end, we return 1. That was the reason that I used 0 and -1. I hope that this was helpful to you. I know that as I explained, things got quite messy, and my explanation might not be like super clear to all of you, but I hope you got the main idea. See you in the next videos.